Hi everyone, in this video we're going to learn how to draw Lewis structures. We're going to focus mainly on single bonds in this video. I want to go over some key facts before we start practicing drawing them. Drawing them is the best way to learn how to do this. The more that you do, the better you will become. It's kind of like a math problem. I'm going to go over some key facts and then I'm going to practice using the dry erase board. Okay, here we go. So some basic instructions. You always want to count the valence electrons. Second step is you want to place the least electronegative element in the center. So this is typically carbon or boron, or if there's only one of something, that always goes in the middle. Hydrogen will never ever go in the middle. You want to put the remaining atoms around the central atom. You want to keep it symmetrical if possible. So the left side, the right side, we want to keep them symmetrical. Once we have everything drawn out, we're going to add our single bonds between the center and the outer atoms. And then we're going to add lone pairs to the outer atoms first, and then you can add lone pairs to the inner atoms. So remember, we want to make sure that each atom has 8 electrons. If not, then you can start doing a double or triple bond, and that will be another video. Remember, 8 is great, so everybody wants 8, okay? There are a few exceptions to the octet rule. The first one is hydrogen. Hydrogen is happy with just 2 electrons. Boron is happy with just 6, phosphorus is happy with 10, and sulfur is happy with just 12. So those are a few exceptions to the rule. So hydrogen will always only make 1 bond, something to keep in mind. Fluorine, chlorine, or bromine, if it's not the central atom, will only have 1 bond attached to it. Carbon and silicon, they can have 4 bonds coming from it, and oxygen, if it's not the central atom, can have 1 or 2. So when I say a single bond is going to be represented by 1 line with an element on each side. A double bond would have 2 lines, and a triple bond would have 3. So each line represents 2 electrons. So if there's a single line, it's 2 electrons. If there's 2 lines, it's 4. And if it's a triple bond, it's going to have 6 electrons. Typically, you only see doubles and triples with carbons, nitrogens, oxygens, and sulfur, but remember, we're going to talk about double and triple in another video. Today, we're only going to focus on single Lewis structures. So let's go ahead and get started. The best way to learn this is to practice. Okay, here we go. I'm going to move back over to my dry erase board and make my screen large so that way you guys can see the board in its fullest and entirety. Okay. All right. It will be helpful if you have a periodic table nearby, just so you can refer to it as well. Okay. The first one that we are going to draw together is BF3. Okay. We're going to do covalent bonds first, and then we're going to tackle ionic bonds. Okay. We know that this is covalent because there's 2 nonmetals. The first thing you want to do is list your elements, B and F. Then we're going to count how many there are. There's 1 boron, there's 3 fluorines, and we're going to multiply this times the valence electrons. So boron is in group 13, so it will have 3. 1 times 3 is 3. Fluorine is in group 17, so it will have 7. 3 times 7 is 21. We're going to add these together, and we get 24. So when we draw out BF3, we know that we have to use all 24 electrons or it's not a complete Lewis structure. So since there's only 1 boron, we know boron's going to go in the middle. There are 3 fluorines, so we're going to place 3 fluorines around it. Now we do either keep the left and the right the same or the top and the bottom. So I have the left, the right, and the bottom. I only have 3 fluorines. If there was a 4th, it would go at the top, okay? Now, right now, all of those elements are just hanging out in limbo. We need to connect them. So we're going to connect them with a single bond. A single bond is a single line. Now, each line is 2 electrons, so I'm going to write a little 2 there. So we've used 6 electrons, 2, 4, 6. So that means we need to use 18 more. Now, boron was an exception to the rule. It is happy with 6, so boron's actually already happy, but our fluorines are not. Fluorine needs 8. So this fluorine right now currently only has 2, so we are going to add 6 more electrons to fluorine. 1, 2, 3, 4, 5, 6 dots. If I subtract 6, I now have 12. Now, a line is a single bond, but a dot is considered a lone pair. So there are 3 lone pairs on fluorine. But 1, 2, 3, 4, 5, 6, 7, 8, if you count them all, this fluorine is now happy. So we now need to go to this fluorine. We need to put 6 dots on this fluorine to make it happy. 1, 2, 3, 4, 5, 6, 7, 8. So that fluorine is now happy, and we used another 6, so we can subtract. So now we only have 6 left to go. So our last 6 are going to go on this fluorine. And now we use 6 more, so we are happy, okay? Now this is a happy structure. We have our single bonds, and like we said before, boron was happy with 6, so there's nothing gonna go at the top here. So it is an asymmetrical one, okay? All right, let's do another one together. Let me erase. All right, the next one that we're going to do together is Br2. Okay, so we're going to start the same way. We are going to list our elements. This time we only have bromine, but there's 2 of them. Bromine is in group 17, so it has 7 valence electrons. 2 times 7 is 14. So we're going to draw them out. So we have a bromine and a bromine. Okay, they're going to be next to each other. Right now, nothing is connecting them. We need to tie them together. So we're going to connect them with a single bond. Remember, a single bond is 2 electrons, so that's 2. So we've used 2, which means we have 12 left. So since we have 12 left, we can put 6 on each side. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So then we used all 12. Okay. We used all 12, and each bromine is happy because each one now has 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we can see that each bromine is now happy because they are sharing the 2 that are in the middle. Okay? All right. Notice when I do the dots, we do 2 on each side. There's never a group of 3 that is together. Okay? I'm going to do another covalent with you. Okay. The last covalent that we're going to do today is CH2Cl2. So once again, I'm going to make my list. I have carbon, hydrogen, and chlorine. I'm going to count how many there are. There's only 1 carbon. There's 2 hydrogen, and there's 2 chlorine. So remember, anytime you have a capital letter, that's a new element. Our next step is to multiply times the valence electrons. So carbon is in group 14, so it has 4 valence electrons. So 1 times 4 is 4. Hydrogen is in group 1, so 2 times 1 is 2. Chlorine is in group 17, so it will have 7. 2 times 7 is 14. We're going to add them up. 4 plus 2 is 6. 6 plus 14 is 20. Okay, so now we need to go ahead and draw this. First, we have to decide what's going to go in the middle. There's 2 chlorines, 2 hydrogens, and only 1 carbon. Since there's only 1 carbon, that carbon is going to go in the middle. Now, like we said before, we want to keep things symmetrical. So we have 2 hydrogens. I'm going to put a hydrogen on the right, and I'm going to put a hydrogen on the left. We have 2 chlorines. I'm going to put a chlorine on the top, and I'm going to put a chlorine on the bottom. This keeps everything symmetrical, so the left, the right, the top, and the bottom are all now symmetrical. Okay? We need to connect them right now. Right now, everything is just hanging in limbo, so we're going to draw a single bond to connect everything. Remember, each bond is 2, so 2, 2, 2, and 2. So we've used 2, 4, 6, and 8. So that means we have 12 electrons left. Now, carbon is already happy. I'm going to put a little check mark there because carbon's already happy. Okay? Oh, the green's a little hard to see. Let's try blue. All right, so carbon is now happy because it has 8. 2, 4, 6, 8. Now, hydrogen is actually happy too as well because hydrogen already has 2 and hydrogen can only take on 2. So hydrogen, each of these hydrogens are also happy. If you think about it, this makes sense. Since hydrogen only has 1 valence electron, taking on 1 more is a huge deal. It wouldn't be able to take on 3 or 4 or even 8. So each hydrogen is happy with 2. Now our chlorines are not happy. They only have 2 each, but we have 12 left. So since we have 12 left and 2 chlorines, we can divide them evenly. We can put 6 on each. Right? We now used all 12. Get a nice smiley face. Okay? And we can count them. 1, 2, 3, 4, 5, 6, 7, 8. So this chlorine is now happy. And we can count this one. 1, 2, 3, 4, 5, 6, 7, 8. This chlorine is now happy. Okay? All right. So hopefully you are starting to understand covalent. Ionic is a little bit different. I'm going to go ahead and do some ionic practice with you guys as well. I do want to remind you that this is one of those things, the more practice problems you do, the better you will get. There are exceptions to the rules, the hydrogens, the borons, the phosphorus. The more problems you do, the more familiar with the rules you become and the more comfortable and confident you are at drawing them. Okay? So remember that was covalent and they were sharing electrons. Now we're going to shift to ionic. So we have K, Br. We know it's ionic because potassium is a metal, bromine is a nonmetal. In an ionic bond, they're going to transfer electrons, so they're no longer sharing anymore. So we're still going to make our list. K and Br. Potassium has 1, bromine has 7. Okay? We're not going to multiply this time. We're simply just going to, well, you can still multiply times 1, so that's 7 and 1, okay, because they're both 1. So now we're going to draw them. We have K and Br. Now I always like to draw my potassium or my metals valence electrons with an X. Potassium only has 1 valence electron, so I'm going to put 1 electron there, and I always do it as an X, and you're going to see why in a minute. Bromine is our nonmetal, and it has 7. 1, 2, 3, 4, 5, 6, 7. So, like we said before, everybody wants 8 in order to be happy. Bromine has 7. Potassium has 1. It's way easier for potassium to give up 1 than for bromine to give up 7. It's way easier for me to loan you $1 than to loan you $7. So, potassium is going to give its 1 to bromine. So, since potassium lost 1, it's now going to have a +1 charge. Remember, when it loses electrons, it's actually positive. Now, bromine still had the 7 from before, but now bromine also has 1 more as well. And since it gained an electron, it now has a -1 charge. So we have a +1, a -1, and they balance out. Your charges must be equal, your positives and your negatives, okay? There's no single bonds or double bonds or triple bonds here. They're simply transferring the electrons, so potassium gave it up. It has nothing to do with it anymore, okay? All right, let's do one more ionic compound together. Okay, so the last one we're going to do together is CaCl2. Okay, we know that calcium is our metal. We know chlorine is our nonmetal. Okay, I'm going to make my list. Calcium and chlorine. There's 1 calcium and 2 chlorines. Okay, We know that calcium is in group 2, so it has 2 valence electrons. Chlorine is in group 17, so it has 7. Okay. I'm not going to add them together, though, because we're transferring the electrons. Okay, so I'm going to draw it. I know I have 1 calcium, so I have 1 calcium over here. Calcium is our metal, and it has 2 valence electrons. So I like to do my valence electrons with my X's, just so we can clearly see. Chlorine is in group 17, so it has 7, and there's 2 of them. Now we said chlorine had 7, so I'm going to put 7 dots around the chlorine. Okay, so we can see that calcium has 2, and each chlorine has 7. So each chlorine still needs 1 more, so it's very easy for the calcium to give 1 to each. Okay, so now we can redraw it. We have Ca, that's a +2 because it lost 2 electrons. So now chlorine is going to still have its 7 from before. Still going to have its 7, but this time it gained 1. So this chlorine is going to be a -1 charge. And I can draw a little line to separate those. This chlorine still had its 7, but it gained 1 as well. So it now has a -1 charge as well. So that's our ionic bond. We see that calcium has a +2, and each chlorine has a -1. -1 plus -1 is -2. Our charges are balanced, so they are equal. Okay, so covalent, a couple things to keep in mind. Remember, covalent has more of the single, double, and triple bonds. Ionic is transferring electrons, so you're gaining and losing, and you're establishing positives and negatives. Okay, the best way to get better at this is to practice. Okay, eventually we will get to double and triple bonds, so stay tuned for that.